When I bought this lathe some 25 years ago, I could not figure out how the spindle bearings were lubricated. The first upgrade was a pump that drew oil from the drain plug and sent filtered oil to two nozzles directed at the bearings. I later discovered that the bearings were set up for oil lubrication. Their housings are fitted with screw-back seals and there are drain holes to return oil to the sump. The bearings are lubricated intermittently so as not to overwhelm the screw-back seals and leak out. When a selector valve is set to dump, oil can be circulated without any leakage. When the clutch is engaged, a timer controls the oil pump. Tests showed that there remained enough oil in the bearings between squirts. Here's a quick overview of the previous system. Oil is drawn from the headstock drain plug, through a shut-off valve, by a gear pump powered by an electric motor, through a car petrol filter, to two nozzles in the headstock directed at the spindle bearings. Previously, the nozzles were fitted to the headstock cover. Apart from the pipe being in the way, access to the gearbox was a hassle. This plate shall become the filter housing. This represents the filter. And this the area of the pump mounting point. I had to true the side where the filter shall be fitted to, on the surface grinder as I could not hold it in a satisfactory manner in the mill. Well, there are ways, but I still intended to finish it on the grinder. I shall use this optical alignment tool I made to align the mill axis with a mark on the plate. It's reasonably accurate when a DRO cannot be used. The tool has a very small circle at the face close to the plate. The image of the mark and circle can be viewed from the side, due to the optical principle of total internal reflection. And it's just a question of aligning the marks. The hole needs to be around 21 millimeters, no need for precision at this stage. It is first hogged out with a hole saw and then finished with a boring head. The cutout is made to match the contour of a feature on the pump body. And the two mounting holes are drilled and tapped. This bolt shall become the threaded boss where the filter shall be fitted. It is first turned to 21 millimeters to be pressed in the plate. The section to be threaded is then turned to 20 millimeters. A thread gutter is cut. The part is threaded M20 by 1.5. It is then drilled through. The part was flipped around. It was drilled and tapped for a fitting. This spacer shall enclose an O-ring, just in case the press fit isn't enough to prevent leaks. I machined 2 fittings to connect the hoses to the filter assembly. A hex is milled using a collet block. The collet nut is used as a stop. A barbed fitting is turned on the other end. The inlet hole is drilled and tapped. The hose fittings are assembled, copper washers are used as seals. The inlet fitting is well within the filter O-ring. The headstock drain plug was widened and tapped for a larger fitting. The filter can now be easily replaced. I filled her up, now let's see if it works and check for leaks. It shouldn't take that long for the oil to get to the nozzle. The spluttering indicates that the pump is drawing air at the inlet fitting. I upgraded the pump inlet fitting. And after purging the air, it works as intended. The pump and filter system is ready. Next in line for replacement is the oil delivery system to the spindle bearings. I would like to be able to replenish the oil without removing the cover without the pipe in the way, and to easily dredge all the oil left in the sump after draining. To filter the oil without overwhelming the screw back seals and leaking out of the gearbox, I shall make a selector valve that directs the oil from the nozzles to the sump. The valve body is bored and then reamed for the valve stem. It is then bored for the valve core. The DRO is used to set the auto carriage stop to trip at the required depth. The valve stem is turned. Followed by the valve core. I use a shear tool to creep to the desired dimension and obtain a superb finish at the same time. The shiny portion is a sliding fit in the valve body, while this part is a temporarily press fit. The valve stem is drilled and tapped to connect to a knob. Perfect. The core is pressed in the body. This will allow me to drill the oil passages through both parts. And finally I can turn the valve body. A plug is turned for a press fit in the valve body. The DRO is used to turn the shoulder so that the plug is just clear of the core. The excess is then faced off. The valve is held in the square collet block I made. A ball detent shall be fitted here. The inlet port shall be drilled here. This is one of the bearing nozzle, and at the intersection, the dump port shall be drilled. First the ball detent is machined. I drill through the valve stem with a 3 mm drill, forming the two detents. I then drill part way through one side of the valve body with a 4 mm drill. I shall use a 4 mm ball. The hole shall be completed with the stem removed. The inlet port is drilled through one side of the valve body and completely through the valve core. It is counterbored for the inlet fitting. The collet block is rotated by 90 degrees, with the nut set against the vice jaws. The outlet ports which direct oil to the spindle bearings, are offset from the center. Drilling through forms the outlet ports in the valve body and internal passage in the core. The outlet passage intersects with the inlet passage. Next, the dump port is drilled through the valve body and valve core. Keeping the same Y-axis position, the collet block is turned vertical. The valve body is centered, then drilled. And the dump port intersects the inlet passage. The valve is disassembled. The section of the valve stem that was a press fit in the body is filed for a sliding fit. The 4 mm hole for the ball can now be drilled through one side of the valve body. The valve core is set to the dump position so that the dump port can be aligned before the plug is pressed into the valve body. The ball detent is assembled. To lubricate the spindle bearings, oil enters through this port. And out the 2 nozzles. 2 sections of pipe shall be pressed in the valve body. In this setting, the dump port is closed. The valve core is turned by 180 degrees to the dump position. Oil can still enter the valve core. However, now the outlet ports are closed. And the dump port is opened, so oil goes back in the sump instead of the bearings. A shoulder is turned at one end of the oil feed tube that will fit in the valve body. It is flipped around and a thread is cut. A taper is cut to fit a flared tube fitting. The tube is then drilled through. The tube was pressed in the valve body and tacked in place. A hole in this piece of angle was used to guide the pilot drill through the headstock. Since I can barely fit the drill, I resorted to a hole saw. The carbide hole saw makes short work of the headstock. And this is how the valve fits in the headstock. A fitting shall extend through the cover and a knob fitted to it. The rear end of an insert holder is used to form a nozzle at one end of this small diameter pipe. The two pipes need to be bent to direct oil onto the bearings. I use a piece of wire rope that is a close fit in the pipe to prevent it from getting kinky. The pipe is then pressed into the valve. The valve is then assembled. It is leveled, otherwise the knob would be canted. I use this piece of wire as a guide to bend the feed tube to the required angle. And it is connected. The extension that connects the valve stem to a knob is machined. This lock nut allows me to locate the flat on the knob where I need to. The knob fits perfectly and covers the hole previously used by the oil delivery tube. And now, thanks to the new sight glass, I can use the filler port I made ages ago. And it works. Now, in addition to intermittent filtering, I have the option to filter the oil in bulk. Might as well replace this relic from the past to a 3D sight glass. After drilling out the bulk of the material, I use a center cutting end mill to square the bottom. I use plenty of coolant and go slow. Already looks the part. The body of the sight glass shall be turned from this bolt. The parts shall come together like this. The bolt is drilled to 12 millimeters. The head is opened up to take the sight glass. The DRO is used to measure the bore length. I put some epoxy on the mating surfaces for good measure. Fingers crossed it doesn't crack. Now I can relax my butt cheeks. When I need to replace the oil, I can undo this fitting and connect this one. The pump can then be used to suck up all the remaining oil.